Okay, so this is Rust and C++ Cardiff's 6th meetup, I think. We started off with the birthday party last year, and then we've been kind of going from there. This is our first one of the new year, and obviously it's a little bit different. We were a bit slow to start, and then we all got quarantined, so on our own head be it. We've got a Twitter and an email. We're trying to get better at using Twitter. Myself in particular, I'm not a great tweeter, but I'm trying to learn. So trying to use that as kind of a communication platform so we can all interact with each other between meetups and share stuff we find interesting. And we're looking to do meetups still monthly, probably virtual for the next 3 months minimum, but it means we can do it from the comfort of our homes, which is always nice, but it means no free pizza unless you brought your own. We've got an email, so if you ever want to do, there's a typo in this, Chris. That's Cardiff. I hope that's not our email, but it's RustAndCpp Cardiff @gmail.com. So just drop us an email if you want to do a talk or just want help getting set up with an environment or anything, or you can tweet us. So we're definitely trying to learn and share and interact with each other and improve our own C++ and Rust knowledge, as well as kind of meeting new people. It's kind of not easy to know who else is working in the same field as you without things like this. And yeah, I'm trying to communicate better and improve our solutions to problems and generally just get better. 2 of us work for Esri and they sponsor the meetup page itself. So this is Esri's logo. But we've also got Krzysztof. What company are you from, Krzysztof? I always forget.
I'm from Fortune Technologies in Bridgend.
Technologies. And Dan, what were you with?
I'm with Nielsen.
Nielsen. So yeah, and we kind of organise it, and then we've got Ewan speaking as well. Where you work?
Bristol University.
Bristol University. But yeah, we're open to speakers from anywhere. If anyone does want to get involved in helping to organise and run it, then again, just let us know. We're a welcoming bunch. And we have a code of conduct. We try and follow the Rust code of conduct because it's pretty good, and that links to the citizens code of conduct. The general overarching thing is kind of be wonderful to each other, treat each other better than you have to, and yeah, enjoy yourselves. We have a Pac-Man rule for real meetups, which is generally just if you're having a discussion, try and leave a gap. So if anyone's new and rocks up, they have kind of an entry point where they can come in and join in the discussion, which again just comes into just be wonderful to each other. And with that, I'm going to show what we've got coming up. So Chris is going to give us a little talk on his experience of creating a great crate, which I think was quite an endeavour. So it's a bit fun. I mean, obviously, it's such a great platform for sharing crates because of Cargo. So I'm really interested to see how that turned out. And then Ewan's doing a talk on computing on the GPU using CUDA. Dan's doing one on getting started with Kubernetes on K3S on a Raspberry Pi. And then Krzysztof, we finally get to see the end of Krzysztof's ABI talk. For those of you who weren't there at the last meetup, Krzysztof got called off in an emergency, like mid-talk, and it was very dramatic. So we never found out how that ended. So looking forward to hearing.
First it was fire alarm, and now it was pandemia that was trying to stop us, right?
Third attempt, third time lucky. We will get to hear it. So with that, I will pass you over to Chris.
All right, thanks, Ciara. Let me share my screen here. So I've never kind of really done this online before, so if this is an absolute train wreck, I do apologize. It should be okay. So usually when I do presentations, I like to have a bit of banter with the audience. Of course, it's going to be really difficult to have that on this kind of platform. So if you've got any questions, just kind of save them up for the end. And then hopefully Ciara can kind of like nudge me with what those questions are, if you don't mind, Ciara.
Yep.
If you see anything kind of like really important that kind of comes up in the chat whilst I'm kind of presenting, just let me know as well. So this is me. You can check out all my Twitter for all the rubbish tweets that I make, etc., etc. So anyway, so what am I talking about? So it's how to create a great crate. I've been practicing that line for weeks now because it's actually quite a mouthful to say. It should take about 30 minutes to do this. So really, this talk is about my experience with developing and publishing crates to crates.io. And hopefully can give you an insight into what is required to publish a crate so you can make it great. And you should make it great, because what's the point if you're not publishing good code, if you're not creating projects which are public projects which are good. So I'm just going to go through today my experience with it, some things that you might learn from it, and also we're going to have some live technical demos, which is going to be interesting. So what is a crate? So let's just make sure that we're all kind of working on the same levels here, because there could be people who are unfamiliar with crates and cargo and Rust. So this is a great crate, but not the great crate that we're going to be making today, or the great crate that I have made, or just a crate that I've made. So crate is a package, and cargo is the package manager for Rust. Crates.io is the registry where all these packages are kind of kept. And I would say that it's crates.io or cargo is the Rust ecosystem. Rust is designed in a way that you can have other package managers if you wanted to, but there's absolutely no reason why you would ever want that, because cargo has been implemented so well into Rust. It's so seamless with the workflow that really that you don't need another package manager. And also the Rust community is really strong and supportive, and we'll see an example of that kind of later on. Okay, so here is an example of getting a crate. So this is log dependency. Oh, can you see my mouse? Yeah, I'm pretty sure you can. So in our cargo.toml, we've got a dependency, we've got a log, which is a crate. And then in main, we're just using this crate. So when you run that, when you do cargo run, it should automatically pull. So yes, let's try that out now. So let's try a little bit of live coding. So if I create a new project, if I do test new proj, then I can cd into it. This is a very strange experience. Okay, so so this is crates.io. So this is where all those crates are kind of held. Let's just kind of pick one. Let's go for rand because that's used quite a lot and also pretty important. So we're just going to copy the dependency here, and then we're going to open up our cargo.toml, and then we're going to paste it into there. Let me know if I'm going too fast as well. Ciara, I'm working on multiple screens, so you're going to have to shout out to me if I'm going too fast for people. I don't know what my video stream is like.
Seems good so far. Yeah.
Cool. All right, so we're just going to main, and we can just paste this in. So let's see how this kind of works. Do they have a documentation page? Yep. Okay, this looks good. Let's take this and we just chuck it in, write it out, let's close it out. And then if we just do cargo run. So I've already pulled down these packages before, so it doesn't need to pull them down because it already has them on the system. So it just compiles them in. And then we have it right here. So we got printed this Chinese character to the console. So you can see how unbelievably easy that was just to pull down a crate and get that building compiling with what, less than a minute, less than 30 seconds. Okay, so here's my project. So I've been working on a project called Chord Composer. The reason why I've been wanting to work on this project is the fact that I'm a composer and I need a tool to help me compose. To be honest, I'm a rubbish composer, so therefore I need help. The tool has to aid in the creative process. It can't get in the way of my current workflow. I want it to be command line interfaced, so I can take it on the train, I can build it on my network, I can, whenever the mood kind of takes me, I'm like, oh, I've got a really good idea, I want to explore that, I can do that on the command line. I also needed it decoupled from my production workflow, which uses quite a lot of different tools. I'm not going to get into that, but if you're interested, I'm quite happy to ask questions about it, or we can take those conversations offline. And importantly, it has to be lightweight. Okay, so here's a demonstration of it running. Okay, so you can see here, hopefully you can see, my command line arguments that I've passed in. So it's cargo run release, and I'm using the play command. I'm giving it a YAML file where my composition lives, and I'm passing the ticket beat. So I don't know if you're going to get sound, but I'm going to play it anyway.
Don't think we can hear it, Chris.
Okay, well, you're gonna have to try that out for yourself then if you want some sound. I don't know how I can get that working straight out of the box. So just imagine that there are some pretty discordant chords being played here, and what this is doing is it's running from the YAML file, which is here. So this is a YAML file that kind of like describes the composition. You kind of give it chords, and then you can basically put these chords into patterns in the music time. You can transpose them, and then you can use things like question marks, which kind of randomize which chord is being used. So if you don't really know how you want to play, you don't know which chord to use, you just want to explore the space, just put a question mark in, and each time you play it, you play a random chord. Also, having the key change up here at the top is a really easy way to explore what your composition sounds like in different keys. So that's an example of it kind of playing the YAML file. Another really important part of this tool is for me to be able to export it into MIDI data as well. So I can export it into MIDI data, and you see here it's created 2 MIDI files, which is each one of the patterns which was described in the YAML. Then I can bring it into my digital audio workstation, and I can kind of play with those chord arrangements there, and then I can move on and I can make leads and basses and things like that from that. So that's kind of, in a nutshell, kind of like what the tool is for me and why I use it. Yes. Hang on. Yes. Okay. So okay, so the music timer in this, so when we're kind of counting down and we're kind of playing the notes in music time, it's not very, so well, it is a very common component to have of music-based games, of these types of music tools and DAWs and things like that. So the first thing I did was I went onto crates.io and I went to see if I could find something like a music counter or a music timer, and there was nothing there. So I was like, okay, well, I'm going to have to build my own. So when I was making the tool, I built my own music timer, and I was like, oh, this is a great idea that I can spin out into my own crate, which I can then publish. Big question is, though, is I've got this interface and I've got this chord composing tool, which I showed you through the YAML, and the question is should that be its own crate as well, or should that be just a repository that people can use, like an open source project that people use and not part of crates? So I went to the Rust subreddit, and this is an indication of how good the community is. So I posted my question: should I publish a crate for my project? I have made my first open source Rust project, and I'm unsure if I should publish this as a crate. On one hand, it's a specific and narrow tool that will have little use as a crate. On the other hand, I have already casually built the engine as a library with a command line interface built and a terminal user interface planned that are both interface with it. Therefore, if people want to use the tools engine, they can interface with it however they want. Do you have any recommendations? And they got back to me saying basically that you should publish both crates, and that usually crates.io, so this topic, this comment down here is actually pretty important. He suggests that crates.io is the first place that he goes to find Rust code. which is pretty interesting. That it's just it just shows how strong the community is around crates.io. And as we saw earlier, it had about 3 billion. I'll have to find it now. So there's been over 2.5 billion downloads of crates via crates.io, which is massive. Just it's a lot larger than what I think Conan is. Okay, so here is like an overview of the components with like the architecture in mind. So we've got music timer up there, which basically just looks after firing events in music time. And then underneath, which kind of uses music timer, is Chord Composer, which is a tool which allows you to compose music. And then we have the Chord Composer interface, which is like the command line or the terminal user interface that kind of uses it. And then other people can kind of hook onto that. Okay, but the problem is now, okay, is that we've created an open source project and it's pretty massive. So, you know, something that I've was hacking at quite a bit, and now it's just turned into a large responsibility. I've got 3 open source projects and I've got 2 libraries. And then I got the responsibilities of now looking after those open source projects. So now I have to be concerned about documentation. I need to be concerned about example testing and continuous integration. That's supposed to say good, but God API design is probably means just as much. Godlike API, and also versioning. So now I have to be concerned about actually running and maintaining projects that have to be pushed and published. So that's something to consider if you want to consider to publish. Okay, all right, so let's just figure out how we're going to publish. So if you've never published a crate before, this is how we do it. You just type into command line cargo publish. As simple as that. So let's actually do that with our project here with Chord Composer. So, so if I open up the Chord Composer, which is the middle element, the middle component, and ooh, good grief. And let's probably change the spelling because I've probably made loads of those. So player composition starting from the composition's pattern index and time. Okay, so we've made our small change there. We're going to save that out. And now we're going to do cargo publish. Now it's recommended before you do a cargo publish is to use the dry run what's it, tag? Yeah, dry run tag. So now it kind of tells you everything that's kind of wrong. So one of the first dependencies that you need to actually publish is actually to have this as an open source project on GitHub specifically. So if you don't like GitHub, you can't publish because you need GitHub. So I'm gonna quickly add this up. I don't know, I'm not prepared for this. I'm just gonna do spelling mistake, spelling fix. I apologize.
If you could type in your PIN number for us while you're at it, Chris.
Yeah, no worries, we'll do that next. Right, so now if I run this again, it should complain because I haven't updated the number. But before it publishes it, makes sure that it can build, and I think it runs some tests. We will find out very, very quickly. Fortunately, there isn't a lot going on here, so it doesn't have to compile that much, but Rust is known for its slow compile times. So
So just to confirm my understanding, Chris, although you've only made a small change to your code, because your code pulls in all these other crates, they all get rebuilt as well as part of the publish process?
Yeah, they get pulled in to see if what you're publishing can actually be built. So it's not publishing those crates as well that I'm using. It's just making sure that what I'm uploading is actually good and working code. So the dry run is complete. So now I'm going to publish it for real. So just talk amongst yourselves.
So what was the point of dry run? If it probably stopped publishing if something went wrong, right?
So dry run is, it goes through the same process of publishing without actually publishing it. So if you're unsure of what you're doing, you run it with a dry run tag first to make sure that everything's okay. So because you published it, that's it. Like you can't get it back. You can't remove it. So this is the failure that I expected it to happen. So now I have to go back in and I have to just change the version number. So it's quite strict on the version numbers that you give it. So when you publish up, those numbers increment, which is a really good way of just, you know, forcing you to be good about your versioning control. Right, so if I publish this again, oh, I have to push it again. Sorry. Okay.
In your TOML just now, you had a repository. Can you point that at GitLab or no?
No, it has to be GitHub. I tried GitLab and it didn't work because I prefer GitLab. Right. So now if I publish this again, we have to watch this build. I'm sorry. And hopefully, and we are nearly there. That's exciting. Okay, right. So apparently it's been published successfully because no error has been returned. So if we go onto here, and let's just do a refresh page, it might pop up on the right-hand side. Yeah, so core composer has just been updated. It has now been updated 3.1. And that's just the documentation I got for the page. Great, so the publishing worked. That's fantastic. Okay, now here's a practical element though. What happens if you wanted to work on chord composer and music timer at the same time? Say I'm making large changes to music timer, but I also want to work the three of them in the stack. So what we can do here is, I'm going to go back into them. If I go into the TOML, so the music timer here is to be pulled, the crate is to be pulled version 1.6. Now, if I change this to path, and then I give it the path that I want, which is where, can't type and talk at the same time, which is where the music timer lives, then I think it should work. So now that's been pulled in, now the dependency for music timer is now local. So if you want to work on music timer, let's go and break something, just make sure that actually works. So timer engine sounds important. Yeah, okay, so if we just comment this line out, then what we should see is those tests begin to fail on the music timer side. So we're now running those 3 tests, right, and they've begun to fail. Great. So now if you go down to the chord composer level, the component that we're working on here, which now it's going to pull that in, if we do cargo update, did I, oh, is that what? Good grief. Did I save it? I did save it. Okay, that's interesting. I didn't expect to see that, but that's probably because of my own naivety when it comes to this.
It did say it removed the music timer and added the one from the local path, right?
Yeah, I think you're right. Thanks for that. Okay, so if we just run those tests now, what we should see it just hang forever and then eventually fail on these tests. So these should be pretty instant, and you can see it's kind of hanging. So this is I'm not going to wait for it to fail because it takes too much time, but I think it fails after 60 seconds. So if you kind of, this is a basic demonstration of if you're kind of working in a stack of different crates that you're working on, this is how you can kind of get them to like to work together, or how you can develop on that stack. That's the wrong command. Right, okay, so we've published it, and then I demoed it. Okay, all right, I think we're done. Yes.
So if you tried to publish it with that local path still in there, would it block it, presumably?
That's a great question. So I'm going to use the dry run again because I actually want to do this. Yeah, so you are right, Ciara. So you do need to give it a specific version, and that also works if you give it star. So I don't know if you're aware of this, but if you put star in the number of the crate that you're using, I can just quickly show you this now. So if you do this, then what will happen is it will retrieve the latest version of Sturdy Derive. It will get the latest version of that crate review cargo update. Okay, so conclusion to make a great crate is, first of all, remember that you're making an open source project. So everything that you kind of do on there, you have to do it in the manner of running an open source project, which can be very difficult if you've never done one before, if you're not worried about software development life cycles and things like that. So if you're unsure about how to run an open source project, join another one, or kind of like look at other open source projects. But at the same time, even if you do run it and you run it absolutely badly, it doesn't matter at the end of the day. So if you want to try, it doesn't matter if you fail. There's also library designing challenges. So if you're unfamiliar with how to design a library, you've got those challenges to overcome. So creating clear and concise APIs, really good documentation, lots of tests, things like that. When you publish your crate, or when you make your crate, make sure it's very clear and explicit on the intent of that crate. And also crates.io is the first place that people go to find crates, it seems. So crates.io it is basically. So you just go on to crates.io if you want to kind of find out more on how to do this. Other than that, this has been me, so I can answer any questions if you have.
Chris, if you're just running a project locally, and you've stored off dependencies on various crates, and you've given it the star to use whatever the latest version is, does that mean that every time you run your program, it'll look to see if there's a new version of any of the dependencies, or only when you tell it to explicitly go and look?
Only when you tell it to explicitly go and look. So if I run cargo update, it might have already found one. Oh wait, no, because I didn't save those changes. But yes, you have to explicitly say that you want them. However, if this is the first time that you run it, it's going to go up and look anyway. Okay. So using star is not ideal, and that's why you're not allowed to publish using star as a dependency. And actually, I think it might be frowned upon. But if you're just hacking code together, it's totally fine. But that's what I do anyway.
You also have an option to specify that the version of your library has to be larger than some given value, right? That's normally for a project. Can you do that also for a crate to publish?
Yeah, I don't know. I'm gonna have to look into that.
I would assume so.
Yeah,
right?
I would assume so.
Because then if you have transitive dependencies on, or same dependency from few crates, right, then they can still synchronize on some particular version. If you have one concrete version then probably you might end up with some kind of collision.
Yeah. That's something that I haven't come across, but you must be able to define above a certain version of the crit that you want. Do you have any questions from the chat, Ciara?
No questions in the chat, but Dan sent a little message about how you can link GitLab repos to crates or the comments on it. I haven't read it.
Well, thanks for showing me up, Dan. Thanks a lot for that.
Mate, I did it in the back channel, and Ciara told me to put it in this channel. Sorry.
But
There is
I
no
think
back channel.
it basically says no, so essentially. I think there's
No, there's one on there that is done.
Okay, all right. Well, thank you very much. And
Right.
I'm here all night if you want to ask me any questions.
Thanks, Chris.
Here's Chris.
yeah, thanks for that, Chris. Cool. So now we are moving on. It was you, Ewan.
Yep.
If anyone has any questions later, just put it in the chat window, or if you go on the participants bit, you can do like thumbs up and thumbs down. I can create polls as well if anyone wants to do a poll. So yeah, just put in the chat what you want and we can make it happen.
Okay. So hopefully you can see my screen. Is that okay?
Yeah.
Yeah. Okay. So yeah, as Ciara said, my name is Ewan Fowler, and I work at Bristol University. So my background is actually in cardiac research. However, recently I've been doing some computer modeling to try and understand how arrhythmias start in the heart. So the models that I'm using, they're quite computationally demanding, and so they can be quite slow to run. However, there's a toolkit from NVIDIA called CUDA, which makes it fairly straightforward to write code that can execute in parallel in the GPU, and this can bring quite big performance improvements. So I'm still fairly new to it, but I thought I'd go over or attempt a sort of brief overview of some of the steps involved, just in case it's useful to anyone. So one of the ways the GPUs differ from CPUs is that they're organized to perform sort of the same operation many times in parallel, whereas a CPU could do a few things, but very, very quickly. So whereas a CPU might have sort of 264 cores, a GPU can have in excess of 5,000 cores, and it has its own dedicated GPU memory. So this is useful if you have a large amount of data that you need to process in parallel. And so these are some sort of the uses that it's been used for quite extensively. So in my case, I was simulating changes in calcium ions inside a 3D model of a muscle cell. So what you're seeing here is fluctuations in calcium after a heartbeat. And this is what we believe is responsible for arrhythmias. So this is what the computer model predicts, and then this is actual experimental data. They look pretty similar to me. So the model has to solve for a large number of these calcium release sites over sort of many points in time. And this can take a long time to run. So if it's just the pure
I think we lost you there for a second, Ewan. Can everyone else also not hear him?
Yeah, he's gone for me too.
Yeah, he's frozen up.
Okay, I'm just going to WhatsApp him, let him know just in case he's plowing on. Oh, this looks very cool, so I'm looking forward to hearing about it.
Yeah.
Well, if he doesn't
still
come
sharing?
back, we can just
He's still sharing it, right?
we can just infer the rest of the presentation if somebody else wants to keep going.
Oh, there he goes.
Okay,
No,
it's gone for real now, but he'll be back.
I think you should play some chords now through your music. Just circle the square.
Yeah, but my sound's not working. Nobody could hear any of that awful racket I was making.
You can put the microphone next to the speaker, right? What
Yeah,
could
that
go
was
wrong?
my idea as well.
Too much of an audio purist to do that.
I knew it was going to be something like that.
Okay, I've got you back, but you're muted, Ewan.
Sorry, first hiccup of the night. So if I try and take off where we left off. Okay. Yeah, so basically the part of code that you want to run on the GPU, you define inside a what looks pretty much like a normal function. It's called the kernel. So, and then basically it's a matter of saving the file with the .cu extension and then compiling using the NVIDIA NVCC compiler. So this is what a kind of basic CUDA C++ program would look like. This is the kernel, which I'll come back to. But basically, it's all it really does is takes a pointer to a vector called A of length num elements, and then for a single element within that vector, it just adds 1 to it. So I'll come back to this a bit later. So this is the sort of main program that actually executes on the CPU. And so here I allocate memory for a large vector on the host. And the convention is to name variables that are allocated on the host with a H underscore, or if it's allocated on a device with a D underscore. This is just because the kernel can't access host memory. And then here we just initialize that vector with some sort of random numbers. Then we, so in order to access the data on the GPU, we have to copy it over into the GPU's memory. So here we're just allocating memory on the GPU. So this is using a special malloc called CUDA malloc, and that just takes this additional parameter, which is a pointer to the, so it will return in this pointer the address of the memory space on the GPU. And then, yeah, so this is the special memcopy call, so CUDA memcopy. And again, this just takes an additional argument which specifies the direction of the copy, so whether it's host to device or device to host. So here's some extra stuff, which is kind of specifying how many unique threads to spin up on the GPU. And this is kind of dependent on the hardware, and is I'm not entirely clear on it in my head myself, but basically this is the number of unique threads, and each thread will operate on a single element of data. So, and then this is where we actually launch the kernel. So the kernel is called vector add. So we're launching vector add, and then inside this special triple chevron sort of syntax, this is where we're saying how many threads are going to run. So if we go back up and have another look at the kernel, you can see it basically just looks like a normal function, only it has this double underscore global declaration specifier at the start. And then it also, this is where it sort of specifies what like the unique thread ID is. So there's these predefined CUDA variables, these 3 variables, and they allow you to give a unique thread ID. So if this was just like a normal C++ program, I would be the iterator, like in a for loop, but instead you specify which element using the unique thread ID. So then you just need to, so that will do churn through and process all the different elements in parallel, basically. So then it's just a matter of copying the memory back from the GPU back onto the host, and then freeing up memory, again using this CUDA free to free up the memory on the GPU. So it's fairly straightforward to sort of port C++ code over to use the CUDA C++ extensions. These are the main things that you need to sort of change. You need to use this global specifier in front of the section of code that you want to run on the GPU. You specify which element you're going to be working on using the unique thread ID, and then you define the number of threads and the sort of architecture of your hardware. Not every problem is suited to this type of computing, so there's quite a large latency when you're copying data back and forth between the host and the CPU, so between the host and the device. So it's kind of best suited when you have a lot of computation that can be done with minimal copying back and forth. It runs, so there's CUDA support on Windows and Linux. There is currently Macintosh support, but I think they're removing that support in future versions. It seems like there are wrappers for Rust. It's not something that I've ever used, but I don't know how sort of well supported that is, and if that's something that you're interested in. OpenCL is an alternative to CUDA that seems to have quite mature Rust support, and also is agnostic to hardware as well. So yeah, so hopefully that's kind of just piqued your interest a little bit. It's still all quite new to me, but if anybody has any questions, I'll do my best to answer them.
That's awesome, you. Were you following any kind of tutorial when you got started with this, or were you just kind of reading the documentation and taking it from there?
Mainly, so I kind of inherited some code from another group of researchers that was working on it, so I was kind of working through their code that was quite sort of extensive already, and then trying to work backwards. So yeah, kind of mainly the documentation, but there's NVIDIA produced quite good sort of tutorials and sort of getting started guides, and there's like Udacity courses and stuff and doing it. So there's quite a lot of resources out there.
Cool. And I think Chris has a question as well.
Yeah, thanks. So why, if you know about OpenCL and you might know about SYCL, why did you choose CUDA over them?
So the honest answer is, again, because I inherited some of this code. So this is what was already kind of being worked on. I did look into seeing whether I could sort of port it over to OpenCL, again, just because I tend to work on Mac and it doesn't really run on Mac. I made some progress. I guess the difference with OpenCL, so one difference is it's not single source. So CUDA, the kernel is defined in your main sort of program, so that's quite nice. It keeps everything kind of together. Whereas OpenCL is you define the kernel in a separate file, and then that seems to be, so with CUDA everything is like just compiled all at the same time, and then I think it's up to the CPU to at runtime sort of distribute stuff to the GPU, whereas in OpenCL I think it's compiled when you're running it, I don't know how much sort of difference that actually makes in practice, but the this being able to convert existing C++ code to CUDA is quite simple. The syntax is quite easy to follow. It's a bit harder. There are a bit more sort of like what do you call it? Pragmas, like macros and stuff that you need to use when you're using OpenCL. So it's just a bit harder to follow.
So, sorry, as a follow-up, so given the fact that you inherited this, is there any changes that you would make, like if you would start afresh? Is there anything that you would do differently?
So I need to sort of really dig into it and see. So the stuff that I glossed over about like this sort of stuff, the people who wrote the code, they were using NVIDIA Titan GPU, which is like the sort of, I think it was the top of the range GPU. The ones that we're using, so we're using the high performance computing cluster at Bristol Uni, and they don't have super fancy GPUs. So actually, you might be able to get better optimizations by playing around with these values. But I need to dig into that to really understand and do sort of profiling. There's profiling tools from NVIDIA to actually see how much of an improvement you're getting.
Can I ask you a question?
Yeah.
So you said it's C++. Do you know what kind of flavor of C++ it is? Does it also, can you use like C++ standard library to it? Probably not.
Well, I mean, the thing is, like the bulk of the code is just normal C++. So all of that you can use as much as the standard library as you want.
All right.
I'm not
And
sure.
so
yeah, I'm not sure how. I'm not sure what sort of version of C++ the MBCC compiler is using.
Mm-hmm. So let's assume something went wrong in that kernel code, right? That runs on the GPU. Do you get any stack traces from it? Is there also a chance maybe to debug it on CPU, like to have a compiler special flag that runs it really on CPU and you can step into whatever, and then the same code, if you don't provide that flag, it just runs it on GPU and you have probably better idea of what's going on?
I think that's actually something that OpenCL might be best for. So what you're talking about, just changing a flag. I think OpenCL, it's exactly the same code, and you change a flag, and it'll send it out to the GPU if it's available. Whether there are sort of debugging tools, I think there are. It's not something that I've used, because when the programs crash for me before, it's not because there's something wrong on the GPU side. It's just there's some other mistake that I've made. I think it's, from what I've read, it's harder to debug on the GPU, but I think it's possible. And I imagine it will be NVIDIA tools. If you're using CUDA, they'll have some sort of debugger.
Thank you.
And I've just put a link in the chat with what I think is the language support of CUDA, so that you can see what features it's got and which ones you can't use. I think you can use anything in your .cpp files, but then within the .cu files, it's slightly restricted, but it's a decent amount.
Again, I suppose the thing is, you kind of want to be doing, it needs to be the it's the same operation repeated many times. So you can't really have too many sort of like if statements, and you can't have like branching really inside the kernels. So it's maybe meant to be more restricted.
And I just have one more question. Is there any of the stuff you've got open source? Can we see any of it? Or is it, I guess, because it's part of the university?
Yeah, it should be. Well, it's publicly funded, so it should be available.
Okay.
I could paste a comment or paste in the chat a link to the original code from our group that we're collaborating with, that we've since modified, but you can see the original code to sort of see how it's distributed.
That'd be cool.
Yeah, do that.
Does anyone else have any questions?
I did have a question on the memory latency you mentioned about copying, because I could see that the CUDA mem copy is presumably obviously copying from one array to the other, and is where the time goes if you're trying to copy a large amount of data in or out. And then I was looking at the declaration above of the DA variable for the memory, and I was thinking, well, can you just access that directly? But I'm guessing that the DA isn't actually a pointer into the memory on the device. It's actually some sort of a handle, so that from the main program you can't actually dereference it or look at what it's referencing.
So yeah, so you I guess you initialize this as a pointer, and then you pass that into this CUDA malloc, and then that CUDA malloc returns an address into GPU memory, I think. So you may be able to, I'm not sure, you may be able to access GPU memory from the CPU, but you can't do it the other way around. If you try and access CPU memory from inside the GPU, the program will crash.
Okay.
Yeah, so that's why you kind of need to, and then there's lots of other like optimizations as well. So like each in the GPU, each thread block has its own like local memory, so kind of the same as you want to, if you're writing a program that has to be very fast running on the CPU, you want to maximize your like the L1 cache accesses. The same is true for the GPU. Yeah.
Cool, thanks.
Awesome, thanks, Ewan.
Cool, thanks.
I think the next one was Dan, I think. You ready to kick off?
Can I take a comfort break first?
Yeah, of course. We can.
I think we had a break in
chat
the
amongst
schedule, right?
Yeah, we did. Yeah, it's easy to plow on when you're in a virtual environment, isn't it? Resist that urge.
I was holding off for the break, and then.
Okay, we'll take a break. And, we can chat amongst ourselves. So if everyone wants to unmute themselves, we can talk over each other. Great fun.
I'll post that link just now.
You'll probably find the opposite. Everyone dashes off now to get a cup of coffee.
All right, give me time to read the CUDA documentation. So I've kind of come across it before, but I haven't ever tried writing it. So it'll be interesting to see what it looks like.
Yeah. I was wanting to sort of do a comparison of like before and after CUDA, but it's a bit trickier working remotely, and we've had problems with having my computer and work rebuilt.
Welcome, Lewis. So you just joined. Yeah, so you've joined just as we're taking a little break, so we're just chatting amongst ourselves before.
Oh, that's cool. Yeah, sorry, I apparently the 5-year-old didn't get the memo that there's a meetup tonight, so I had to put him to bed just now, and so I sped through, what was it? It was Oi Platypus and Oi Duck-billed Platypus, classic. So yeah, but I'll catch up on the recording as well, so looking forward to it.
Yeah. This is our, yeah, I think it's going okay so far for a virtual meetup. We haven't had too many difficulties so far. Yeah, Zoom seems to be able to handle pretty well quite a lot of video content, and yeah, it can sometimes be a bit laggy in the share screen demos, but not too much, not to the point where you kind of lose too much.
So when we did the Cloud Native Wales remote one, we had the recording from Zoom, and I think it was like 2 gig in size. And yeah, so the person who recorded it, they went on a stag do on the Friday to Poland, and then on Saturday night, Poland were closing their borders, so he had to, within 4 hours, get to Berlin. And yeah, he ended up getting home. So then he sent me the file. I had to cut some bits out of a meetup, and then the file went up to being 12 gig in size for some reason. And by that point, I was just like, I'm flipping the desk. I can't do video content. And so it's just like, that's YouTube's problem now. Just send it up there. So yeah, just don't edit it. There's my top tip. Or get someone else to who knows what they're doing, which was certainly not me.
I'm hoping it'll just come out perfect out the box, but if not, then between us we'll figure it out.
Just like our code, just push it.
I did notice a very similar effect recording a 5-minute status report for a meeting that as soon as I edited it to try and cut out the content I didn't want, the file got larger. It's as if it just keeps the original one and then just saves everything you edit as deltas on top of it.
It's just taking more content from your machine. It's like taking all the videos and going, yeah, quick, take it all. Yeah. Anyway. I try and solve the problem, but instead I'm just going to wait until we do the next one and then just do exactly the same as I did last time, as I do with most of my life's issues. So.
I think if there's bits to chop out and you're publishing to YouTube, then just put some times in the little summary so people can just skip the chit chat in between to get straight to the talks.
Yeah, that's a good point. Actually, I didn't think of that. Yeah, and yeah. All these lessons that we learn. And I could have shared with you, but obviously I didn't because that's the kind of person I am.
On YouTube, there is also an option for bookmarks, isn't it? Like not only to have links, you said, but I think you can have bookmarks. So on the timeline, you have some specific pipes.
Probably, yeah.
That's something special.
They've gotten quite good with stuff like that because now people embed ads at like certain. I don't think we'll be doing that unless Google forces us.
When I release a video as well, I set it to premiere mode. And I was like, well, may as well go Hail Mary all in on this. So then when I went to press play, it had like a 10-second countdown timer, which I've never seen before. And I was like, oh, this is lovely. And then I think all of 4 people watched it after a week. So all those endeavors. But hey, it's not about numbers, it's about just having it there. So yeah, anyway. I'll sit back now. I'm just going to sit back and enjoy and hopefully not wake up my son in the next room because that would be terrible.
How long is he? How old? All right.
Yeah, he's 5. So first day of homeschool today. And I think as with every other parent, they think teachers should have a huge promotion. Just having a single child at home has been, it's nice, it's awesome fun, and it's like, in the circumstances that we're in, it's meh, but still, 3 whole months.
Hi, everybody.
Hello.
Hiya, Dan.
I apologize. My 2-year-old decided I should put him to bed, and I've just encouraged him with a bit of expression. So sorry. Are you ready for me to try to share my screen? How do I do that? There we go. And we should see Inception now, as you've seen in Inception. How does that look?
Good.
Looks good to me.
Splendid. I hope everyone's back. If they're not, watch the recording after because I'm running late. Have a nice Christmas. Right, yeah, so I'm going to do a demonstration now on getting started with Kubernetes using K3s. A little bit of backstory on this is that I was going to do this talk the day before I actually did this presentation for the South Wales Linux user group, and this was going to be my test run for it. But as it turned out, because we had some trouble with venue, it didn't happen, and I've had time to polish it a little bit better since that first run, hopefully. So who am I? I'm sure most people have come to the meetup and seen me before. In case you haven't, I'm the guy who doesn't really do any C++ or any Rust, although I probably did do more Rust when we started to talk about doing the meetup. And I work in a sort of cloud native world, which is why Lewis is on the call, because he can give me some safe faces as opposed to you crazy hardcore hackers. But yes, I'm literally an imposter here. And I can't even see my show notes, so hang on a moment. And that's showing on your screen, isn't it? No? Beautiful. Right, sorry, my notes. So, what is Kubernetes? Well, I'm very happy that Chris has put up some YAML already, because that is pretty much all the Kubernetes is. And now I'm not getting my slides. Come on, what's going on? Here we go. So when I did the talk originally, I asked everyone to put their hands up if they'd actually heard of Kubernetes, but I guess you can click that little icon on the side. If you've heard of Kubernetes, put your hands up. Video is fine too. Okay. So I got a tough crowd. There's not many people who even heard of it. I was gonna say if you could keep your hands up if you've played with it. And everyone's hand goes down. I guess Lewis's hand should be up, and Greg's.
I tried it on Louis' talk.
Oh, good. And then I was going to ask if anyone's used it in production, but that's just like oh, Jonathan's used it. That's good to know. So I got a very tough crowd here, so I'm gonna have to explain everything. So if you listen to Software Engineering Daily, which I'm sure some of you do, you'll have heard the hyperbolic statement that it's the winner of the container orchestration wars. I'm not sure what wars there were, but it certainly is what most people go to if they're using containers and they want to orchestrate them. So let's start at the beginning. What are containers? And this I pulled this off the Docker website when I did the talk for the LUG the other week, and I think it's a little bit changed because it never used to mention Windows at all. But it's a nice way of packaging code, nice way of packaging the whole operating system. And it from me as a sort of platform engineer, it's a nice way of making sure when somebody says it works on my machine, it actually works in production without having to ship their machine. I mean, it's obviously a nice wrap around some basic Linux concepts like C groups and network namespacing. But it's a nice way of like saying, here's the building blocks of the operating system. I'm going to layer on the bits that I need and trying to minimize all the bits that I don't need and stop ending up with snowflakes of trying to get the thing to work on my dev machine as it does in production. And the basic entry point to Docker is these lovely things called Docker files, which I will show you some C++ ones and some Rust ones because I had some help from some people who know what they're talking about. But this is a sort of Python one. It's a nice step. You have your from, which is the sort of image that you want to pull, but you can start right from scratch, which has nothing at all in it. Where you want to work, things you might want to install, and then when the container runs, what exactly we're going to run. And like copying your source code. So again, what is Kubernetes? Well, this is what the Cloud Native Compute Foundation says about it, which sounds like another load of waffle. Lots of marketing waffle in this space. But I think you can like simplify it by thinking of, you define what you want the state of the world to look like in YAML. You hit the Kubernetes API server with a request to make that so, and then within the scheduler of Kubernetes, there's a reconciliation loop which says, is the state of the world look like what I think the state of the world should look like? And then we get our desired state, hopefully. But if things go wrong, I notify, I say that that's the case, and I try again to do the same thing. Okay, so what is K3S? Well, it started, I think, as a little bit of a pet project for people at Rancher Labs, where they were trying to minimize what is in Kubernetes down so that they could run it on edge computing. But I think it's got a lot got on a lot more than that since then. But essentially, they've pulled out all the things that are not needed to get it to run, and even inside the Kubernetes proper, it uses a database technology called at.the to handle its high availability, multi-write reconciliation data store. And basically, K3S is saying, well, we don't really need that. We just need a database. So it sort of creates an abstraction API between that and uses SQLite in its default configuration. So there are ways of getting it high available, but I'm not trying to complicate anything. And I don't know if anyone has heard, but Kubernetes is quite often shortened to K8S to mean the 8 characters in between the K and the S, and the K3S is sort of a boon to we stripped out the fat, so we're 5 less than K8S. Okay, so now I'm going to live demo how easy it is to get started with Kubernetes by I've literally took the Raspberry Pi that I've been working on for this talk, bought a brand new card earlier today, although that was a bit of a mission with some masks on and trying to socially isolate, but I've got that, and we're going to go from zero to Kubernetes on a cluster, and with some nice I've jumped the gun, with some nice C++ and Rust. So without further ado.
So just a quick one. So you waited to today to go and get the SD card?
I have to do something last minute, right?
Fair play, fair play.
I mean, last time I did all the slides and the work on the same day. I had to leave something. Plus, I've been socially isolated. I've actually had to isolate, and today's my first. Well, yesterday was my first day without symptoms, so I try to avoid the outside world. I got a good excuse, right?
Dan, just can I just check my mental model of what Kubernetes is giving us, or
Absolutely.
Docker images? So from what you described, the way I understood it was it's bigger than just you've got packaged libraries, but not as big as a complete VM virtual machine. It's almost like a vector description of a VM. You use your YAML file to describe what should be in it, and then when you download it or install it or run it, then it ensures your local environment looks like the YAML file says it should look, so you can run the application in the way it was intended.
So that's more of what a container is, more than Kubernetes. So let me go back to that slide, because I've clearly glossed over that, and now that you've asked that question, realized I've missed some stuff out.
It might just be me.
No, it's fine. So in a sort of normal world, you'd think of a VM, right? We're running the whole kernel, running running everything for like being a complete virtual machine. And the great thing with a container is you're not doing that. You're sharing the kernel space, but you are there, so therefore you don't have that fat of having to virtualize the CPU cores and the sys cores. You're actually making genuine sys cores into the operating system. Let's not talk about the security potential problems there, but you're namespaced out, and you as if you're a running process, so that the whole host operating system, even though you're sandboxed, it looks to you like you're running a VM, but you're not. You're sharing the system without having to reload multiple copies of the operating system, if that makes sense. Although it's not quite as simple as that, because on Windows there really is a certain amount of that kind of sandbox VMing happening. But that's more, and in fairness, there are ways in the container space to actually get a VM if you want that level of isolation. But then Kubernetes itself is a way of scheduling these jobs amongst clusters of computers and nodes, so that if a node goes away, another, so say you say, I don't know, I want 3 versions of this to run, but then I make sure, even, no matter how many computers are currently live, that there's always 3 of them running. That's what Kubernetes, that's what a container orchestration engine is, and that's what Kubernetes does.
Okay, that clears up. Yeah, that's a lot better. Thanks.
Sorry. And now I've lost my window. Right. So I know you shouldn't pipe ever pipe summon you curl, but I'm going to. If I can copy and paste.
Are you running inside container?
No, I'm running on a Raspberry Pi. It's brand new, so I'm going to throw this image away tomorrow if it's a problem. And now we find out my internet's not fast enough for this, but I tethered it last time because that's what I had to work against. So while we're doing that, I'll show you some code. So for example, to get a sort of understanding of, so here's my cargo terminal, which we saw a little bit earlier. And my source code is quite simple. I'm basically, although I don't know why I'm doing a counter there. Oh, I remember, because I was going to do a sort of failing thing occasionally to show you live probes. But we're just going to do hello world from the language that it's in. And that's pretty much what I've done with all of these languages. But then a Docker file looks a little bit like this. And I'm doing a multi-stage Docker file here. So I'm pulling from the Rust image, which version 1 and the stretch, which is like Debian stretch, and I'm aliasing it as builder. And then I copy my toml file in and my source code in, and I do cargo build within that container. And then I run a strip on the binary file. And then I make a brand new container which got nothing at all in it, and I just copy the binary off so that we don't have any of the source code in the final image. And then my entry point will just be straight into that binary. And then the great thing that you may not know, but usually when you're building Docker containers or any containers, you're building them in the architecture that you're running. So like as you may know or may not know, a Raspberry Pi is running ARM, and most computers are running like Intel as sort of x86 64-bit stuff. So, but now within Docker, there's the ability to build for multiple architectures with like this command that I'm showing you here. So I'm not going to push just for the sake of you seeing what I'm doing. I'm just going to call it test for the sake of showing the image. And now we've not worked because I'm not in the right directory. Live demo is great. Typing and talking is also great.
What was the strip step doing?
Strips all like sort of debug information that's in the binary and all other kind of nonsense that you as I've mentioned on previous talks, I kind of like small binary size and tried to minimize everything. I was going to try to show you a Scratch container, but I was having trouble with some of the run C requirements that I had, and I gave up. I could get it to run from scratch on an Intel chipset, but not on an ARM, so I gave up just because of time, really. So as you can see, every one of the steps is actually being run for each architecture, and then when you push the Docker Hub, when you pull, it's based on the architecture that you're on, which is great for when I'm going to be on a Raspberry Pi shortly, which now that is installed, great. So if I copy, Sorry, so I'm copying the config for Kubernetes off the Raspberry Pi now to try to use it on my machine itself. I've realized that that's going to point to localhost, and I need to now update that to my Raspberry Pi. It has some great IP addresses. It is definitely more difficult to do a talk remotely than it is in person, and I never thought I'd say that. What am I trying to apply? You. It's not too configured as my father. Oh, beautiful. So now Raspberry, just like that, Kubernetes is now running on my Raspberry Pi, and I'm accessing it across the network from my machine. So let's give you the container that we just made. This is what a manifest, which is lots and lots of YAML, looks like in Kubernetes. So this is a deployment, but in Kubernetes, it's sort of built up from the building blocks of what is called a pod, which is similar to a container, but in Kubernetes world, you can have more than one container in a pod. As you can see, this is still built in, so my internet is going great, and I don't know if you can hear, but my Mac is now on fire. So in a pod, you can usually just put one container in, but there's a way in Kubernetes to add more than one pods and to have an init container. So as the machine comes up, you might want to copy files from the operating system into the container. Lots of different patterns that if you've got questions, I can answer for you later. But essentially, a deployment is a way of saying, I want to have this many pods. And if any die because of whatever reason, I would like you to make sure I have at least, in this instance, 2 pods. And I'm just saying that it's going to be listening on port 8080 and some memory limits for the pod. And the container is obviously the one that I have pushed, which is based up on this. And oh my God. Apologies. Talk amongst yourselves.
Has anyone got any pro tips for if someone wanted to start looking at Kubernetes but has absolutely no experience with Kubernetes or Docker or any kind of containerization?
Hi.
Um,
Do you want me
Go on,
to
Lewis.
take that? Well, do you want, just whilst you debug, I can take that for you if you want, and then you can fill in with anything that I miss.
Yeah,
Container-wise, most times if no one's touched or used a container before, most people think straight away that they need to use Go. You don't, just use whichever language you like. You can start with getting a container up and running, just Google it, just Google a Docker file for whatever language that you're in, and then you'll probably find about 5 lines of code, which start with from, as Dan mentioned at the start, and then just follow those build processes. The thing that Dan's already mentioned as well with that multi-stage build, so the way he's created his images and compiling the code in one container and then using another to distribute it, that's the biggest win you can possibly get in everything, in my personal opinion. So for example, it's if you spin up an application because you've got so many dependencies to compile your app, you can see, yeah, in fact, there's lots of vulnerabilities in there, just because of the basis of the images that you require to build it up from. And then if you use multi-stage build, it's crazy how they can, in a demo that I used to give in training, it would go from 350 errors or like critical issues down to 5 minor ones, which you couldn't really avoid anyway. Yeah, and Oh, if you
Cheers,
do
Greg.
like, are you all sorted? Shall I shut up?
No, it's just Greg's messaged me as a quick win for me.
Cool.
I
Cool.
got you.
Greg's always got our back. If you are interested in containers, have a look at Jessie Frizzell and her Docker files repo, where she's just put pretty much everything into a container, from applications that we use day to day to any random things as well, like there's Spotify in a container and whatnot. So that's kind of a cool thing to look at.
Could you post that in the chat, the person you just mentioned's name? Or
Yeah, I'll do it. I'll share a load of links in there as well. So
Okay,
I'll
cool.
share some of the resources I'd recommend for containers. Also, just hit me up if you want, because I'm just sat at home most of the time now, if not reading a book for my child. And I'm happy to help out where I can. And yeah, but I'll let Dan pick up, because I'm sure he's got some resources that he want to share. So.
Thank you, Lewis. So if those who are watching me debug, for some reason, using the kubeconfig command in a different directory wasn't working. But Greg messaged me to tell me just to put in my environment variable. It's because I'm using the K3S YAML that I just created, which isn't the standard place for the kubeconfig to exist. So I set my environment variable just there, and then I could do it. And now I'm applying, and we're having a little bit of time, but that's mostly because I am building and my internet is downloading this image, which shouldn't be that large, but I bet that the family downstairs are now streaming the internet to try to keep the kids quiet. Oh, working from home is great, right? So how am I doing for time? Because I have backup plans. What time is Krzysztof due to come on? Am I even speaking?
Question. I would say carry on until you're finished, because I can't remember the exact timings. We started at 6:30, so we're an hour and a half in. I scheduled it for hours.
Okay, so then I've done a similar sort of thing for, while that's pulling, I've done a similar sort of thing for Python. No, I haven't done these ones yet, but I've done it for Go, which was my original one. I know this isn't a Go meetup, so I won't show you the code. But then, as you all know, I'm trying to learn C++, and with the magical help of Krzysztof, I've been trying to use Conan to do a similar thing to what I just did in Rust in C++, which was just wild. And we spent a little bit of time, and I never actually got it to compile once I was using an environment variable, because I wanted to change hello world to hello environment variable for whatever world is, as you just saw in the Rust. So I could show you a config map, and we could have hello Rust and C++ from C++. But that's just giving you a sort of concept of different containers. And then back to the sort of Kubernetes world of things. So we've split up now, we've made our pods, which is what runs our code, but to get from the outside world or even internally for you to sort of connect to the deployments, you would need a Kubernetes primitive called a service, which I have made here. And I call it inlets, but the name could be anything. This is just what I'm calling it. And then I've given it a label. And then I am saying that I wanted to listen on port 8080, but I'm also saying to target port 8080. And then I use this thing called a selector, which selects other pods with this tag. And if you look at my deployment that I made for Rust, and in fact for all of them, I gave them all tags of the talk started with K3S on Pi, but then the app was related to whatever language that they were written in. But the reason that I've done this is that when I get to the point of demoing this to you, although we are in a place now to see the pods running, it will select one of the backends. So it load balances the sort of pod that you want to talk to. And based on time, I think I will go to here's one I prepared earlier. So bear with me 2 seconds. I just wanted to show how easy it was to get up and running from nothing to 100. And all this is in a GitHub repo with the same name of starting K8 with K3S on Pi in GitHub. My username is Plod. So you can look at the code after, because I'm obviously doing a little bit of a whistle stop tour. So there's a lovely tool for Kubernetes that's a lot easier than typing all these kubectl commands called K9s, which I will demonstrate to you shortly when there we go. So let me just plug in my other SD card into my Pi, which is here's one I prepared earlier. And this is a little bit easier for navigating through what's going on in your cluster and similar things to that. So let me just power that off and power it back on. This looks a little bit like this. It could be because it's trying to connect to my Raspberry Pi, which hasn't booted yet.
I think you need to save this again.
You are, buddy?
I think you need to save this again. Oh, there you go.
Hey, that's a bit weird, isn't it? That's good though, because it's just the Pi hasn't come up yet. Oh, no sooner than you say that. Thinking about it.
So whilst you're doing this, so how does a client connect to the cluster?
As in,
yeah, just because the Pi's up and running, and so there's something that's in Kubernetes that's receiving all these commands. It was just to add some filler whilst you're doing that. So yeah, it's just the API server. So yeah, when you're using kubectl, it's just connecting to the API server that's hosted on the control plane. So that's probably what we're just waiting for it to get up and running.
Oh yeah, why is it not working? It's good, but I wondered if it's even that and not. It just hasn't started properly. So I'm just SSHing in, and the Pi seems to be a little bit excited. Ooh. Ah, what am I doing? Apologies for the ham-fistedness. Well, when I did the original live demo, I had a little bit of a trouble with exactly that problem, and now it looks like it's winning. I think either it must be heat related. I thought it was to do with the speed of the SD card. There we go. So as you can see now, I've got, in fact, I scaled up my CPP to 10 pods. That could be why we're having some trouble connecting to it. But I also use this open source project called Inlets, which allows you to create it creates a virtual machine for you in the cloud, and then creates a reverse tunnel, so you have a live. So you have a way of getting into your cluster from external. And then in Kubernetes, there's this thing called an ingress controller, which is a nice way of doing like layer 7 routing to your back end, to your services. So if you look back at the service I made, I also made an ingress object. And then I actually give it a host name. And I believe if you go to that URL on your own computers right now, hopefully, as long as I haven't messed it up by using a different SD card, you can see, as I'm showing you now, and if I look at the ingress controller itself, I should be able to watch your traffic coming through if anyone's hitting it, but nobody's hitting it.
Can you share
Come
that
on,
link?
guys. Of course. If I can find that screen. Too many screens. There we go. We're starting to have some traffic coming through, and I just put the link into this thing. And there you can see you're all hitting the Raspberry Pi now on my desk. And just to make things look a little bit prettier, I created a static, pretty Docker file, which just uses Nginx and some nice HTML, and then Ajax requests to the service that you're all hitting. And I have to see my service to remember what the hostname for it. Oh, hello world instead. No, that's yeah, maybe. No, wrong one. Talk.py4. So if you hit talk.py4, and there you go. You're now hitting all of these containers. And if we go to the deployment, and I edit the C++ one, and I change its replicas down from this crazy number to 2. And we now look at the pods, see, and this is that reconciliation loop that I was explaining, where now the scheduler is going, I'm supposed to have 2 of these, I've got 10 of these, I need to get rid of 8 of these. And there we go in the background. Hopefully you're all seeing that. Is everyone still hitting it? And that is my demonstration. Does anyone have any questions?
That was very brave. Well done.
I had backup plans for backup plans. It's okay, but I didn't expect to mumble so much.
That's cool. So just to check I'm understanding it right. So each one of those pods,
Yes.
so it's hitting each one of those pods every time it's kind of refreshing on in the browser. So we're seeing
So
code
if you look at the HTML, it's got like a 2-second delay, and all it does is hit the hello world endpoint. But the Kubernetes service is balancing the load between all of these pods. Okay. And you should see.
Would they all do the same thing? In this case, they say slightly different things, but
Usually you wouldn't do that.
Okay. Okay.
You wouldn't have a service that hits things that do completely different things, but I was doing it to highlight different programming languages doing the same thing. And you can obviously see, although you can't see it, but usually when I do some performance tests, you can see that the C++ and the Rust are doing far better from a memory point of view than the Go version of things. But I guess we're not hammering it enough right now. Oh, there we go. And who goes up? The C++ starts using more memory and everything. Dear, dear. That could be related to the fact that I had 10 and now I've got 2.
So quick one, Dan. You mentioned about pods being able to run multiple containers. Why would you want to run multiple containers in a pod?
So you'd only usually use a pod for one job, right? Like, I don't know, like this, like running a HTTP server, but you'd use maybe secondary containers like sidecars. I think that's the word for it, for sort of like ancillary tasks, like shipping the logs off, Fluentd, shipping your logs off, or like a big pattern at the moment is to use it for a service mesh. So you can, instead of writing a library for your services to how they communicate with each other, how they do service discovery, how they do mutual TLS to make sure they're encrypted, you could offload that to a sidecar process with using a service mesh. And there's in fact one of them called linkerd that's written in Rust. and I believe Istio might be written in C++. So yeah, very topical. Did that answer your question, Lewis? I know it was a helpful question for me.
I'm always there for a helpful question. I think Envoy is written in C++ as well.
Oh, Envoy, yeah, that which is the actual thing that most of them use.
Yeah.
Under the hood.
Thank you, and congrats on your demo.
Really good. Thanks.
Ooh, does anyone else have any questions? But you can ping down after if you think of any. I'll put them in the chat.
Oh, I still got a little bit more of the talk that
Oh,
I
sorry.
always forget to give because I get so excited that my demo did or didn't work. But I keep righty-ho. So I wanted to mention that me and Lewis and Sal have put together a podcast that you can subscribe to. That we've also created a mental health book club to the topic that I spoke in a previous talk about burnout in tech and mental health and how important it is. So if you would like to get involved in that, drop me a line. And since then, another chap who is involved with Instana and me have set up a sort of WhatsApp group, if you might be interested, called the Welsh Mentalists, which is again related to a sort of support group for people in tech facing any mental health issues and want to have a chat. These are all my URLs. I'm Plod or Plod TV on pretty much all the channels in the world. If you need me and I didn't mention anything, hit me up. Have a nice Christmas.
Ooh.
Thank you very much.
Thanks, Dan. Very good.
With that, we will move on to Krzysztof, who will finally get to do his API talk.
We'll see how it goes, right? Let me share my screen. This one. Hello. Can you see the slides?
Yep.
All right. Yep. So yeah, let's have a go at it. So this presentation is about ABI, right? And I called it ABI, by mistake, because I'm not native, right? And by whatever reason, I thought you might say AB, and then it would sound like Austin Powers, AB, baby, yeah. But yeah, it doesn't work. So there was a pun in it, which didn't work. But I said that before, right? The reason why I was trying to talk about ABI is that we're not only living in unprecedented times because of the pandemics, but we're also living in unprecedented times where some people are suggesting to make changes to C++ and the standard library that would break ABI in C++. Those people come from Google and they have reasons to do so. And there is a good question, I would think, to have a think about what the ABI really is. And hopefully I will be able to explain that at least a little bit. Probably I don't understand that fully, but we can all together come to some conclusions, I guess. Yeah, so let's start from what ABI is. And it stands for Application Binary Interface. And when you're talking about ABI, you really are talking about two things. And one is compiler ABI, and then there is also a library ABI. And there is a mouthful of rules what the ABI is, and really it is the way of how your compiler implements the rules of the language and the features of the language. And obviously we're talking here about Rust and C++, a little bit of C. So it all means how the language is translated into the assembly code. And again, the ABI is responsible for allowing you to link one code to the other, be it object files, some libraries, statics, or shared. And obviously ABI, because we're on native languages, so we're running on Metal almost. So we're architecture specific, and that's what ABI is. And the reason for it is performance. So we don't want to have any or much of virtualization on top of your hardware. And also, some of the ABI might be standardized, but it doesn't mean it's a C++ or C standard. There are just some standards that are being used on some operating systems. Usually it's like on Linux systems, there is the Itanium standard. So you could probably read on it if you wanted, but probably not. And obviously, because we are running natively, but most of our applications, C++ applications, are still running in operating system and are using some libraries, some system calls from the operating system. That ABI will have to be dependent on the OS that the application is running, if it is running any application. So this would be the compiler ABI. As I said, lots of the roles, probably not all of them are there, but recently also there was Titus Winters on CPP Cast, and he had his go at ABI, and what he said is that really ABI is just a communication protocol. It's a binary communication protocol between your object files, between your libs, between your executables, and that's what you really should think about. So you have some parts of the code that are reaching to another code, and all of that is really binary, right? So they have to agree on the way of transmitting things around between each other. And if you're talking about library ABI, it's just a combination of a compiler ABI and of a library API itself. So API will contribute to the binary output of the compiler when the library is being compiled. Oops, not here, sorry. So is it important really having that chat about ABI and what the ABI is? And it is really important. And one of the main things that the ABI is used is just allows you to reuse compiled objects, right? And we do care about that because first of all, like we devs can do parallel compilation of the object files, for instance, so of the let's say C++, CPP files. They are, forgot obviously the name, but they are trivially parallelizable, which means you can have like multiple cores with one compiler running on each CPP file, producing the object file, or you can even have a cluster of potentially different version of the compilers producing the same object files, providing that they conform to the same ABI. So you can just scale it and your compilation will should finish sooner, right? So the other thing is that it's not only that you're compiling your code at the same time, but you might be recompiling your code, and there is that notion of incremental builds. So you compile something before that hasn't changed, and in C++ code you would say, oh no, the body of the CPP hasn't changed, CPP file hasn't changed, and none of the included files have changed, and transitive files. So there is no point in recompiling that file. That object file that is there is already a compiled snapshot of the CPP file that is still the same CPP file. So you don't have to do it, which means you save your time, money. Obviously, some of the libraries are closed source, and then you would only get the compiled version of those libraries. Not some people would say you shouldn't use them, but there are cases where you would. And obviously, if those libraries conform to the ABI that is on your machine that you want to run that code, you should be fine. Some libraries have source code that is lost, and that's the case also for the big banks, for instance, that some companies that deliver the code, the binary, they go bust and the source code is lost. You still need to make sure that you are able to use the library that they have provided 10 years ago. And that's also the advantage of C++ code, but that's also disadvantage if you want to introduce new changes to the C++ because of the backward compatibility. And maybe one of the biggest things is that you might have shared libraries on your operating system. And if lots of the executables are using the same shared library, your operating system will optimize that and it will only load the library once. and we'll use read-only pages to share between different processes. So we would just save resources. And also, if your binary or lots of your binaries are using one library, and you just update that library, which is still binary compatible with the previous version, you would just get a patch of one library, but lots of the binaries would use it, right? So ABI is really important, and not necessarily we think about it when we're, for instance, using Linux operating system, and then we're just updating with package manager, and it updates some of your libraries, shared libraries, and your applications are just using newer versions and hopefully are more secure. So I would say ABI is important, but it's pretty difficult, and probably only compiler people will understand the nitty-gritties of that. So if we wanted to have a look a little bit, right, a very small set of what ABI is, I give you that here, right? So one of the things in the ABI, in the compiler ABI, is the name mangling. So let's say you have two files, CPP files. One CPP file that defines say hello, that has some code in it. You compile that file, and then you compile another main or file with the main entry method that is using that say hello. And obviously the compiler sees that externally. It sees that externally, right? And then if your code from main wants to call the method from the other CPP file, that's the linker that will take care of linking one and the other. But to be sure that the linker can see what you really want to call, is that your compiler will create some labels, which are names of particular symbols, in this case, the symbol of the function. So it will create in the object, in one object files, this, the label saying, oh, this is where your say hello function code starts. And then the main CPP would be able to call to this say hello, but by the same label. And you would say, oh, there is no really name mangling in it, but it's just because this is particular x86-64 GCC compiling C code in this case, and it just didn't give you the name mangling. But if you were using a C++ compiler, it would just mangle that to something less readable. And what I'm trying to say is that your caller and the callee, they have to agree on the same way of compiling that name, creating the labels, so that linker can find whatever it wants to find, right? Then there is also another thing. So we already know that the linker will be able to find the function, but obviously you want to pass some function parameters to the function, and you want to get some result from the function. Also, we are using this, or C++ is running on the, or is emulating stacked virtual machine, which means it will have some activations frames. It will that it will be creating for each call of a function, unless it's inlining it or whatnot. And it will have to, so we are using in C++ lots of RAII, and the language and the binary code that is produced from our language needs to assure that RAII is being called. So we are having arguments being passed, and we need to assure that the callee and the caller agree on who creates the activation name, who cleans the arguments, who passes the arguments, how and what is the order of the arguments, right? And how the return value is going to be returned, especially that C++ is giving you also the return value optimization. And you, with the caller, you need to agree what registers are being preserved and what registers are being modified, so that you can store some values if you worry about the state of the register, right? And on top of that, you might have, within one compiler, you will have lots of many conventions, calling conventions for functions. And each of those conventions, cdecl or discall, they will change a way how those parameters, the cleaning of the arguments, and lots of the things changes, right? So again, lots of the text here, but the way how it works on a simple, very trivial example is again to have one CPP file that is just the main function calling sum all, and that sum all takes 7 parameters, trivially copyable, trivially destructible integers. And then in another file, you will have the definition of that sum all, and you just want to see really what the compiler would produce. Again, that's x6486 GCC. And as you can see probably, the way how the compiler works is that on the calling side, it will create, or it will push the parameters from left to right into the registers, EDI register, 2 into ESI register, 3 to EDX, and so on, up to 6 parameters. So those will be stored in the registers. But then the last parameter is not going to be stored on the register. It's going to be stored on the stack, right? So this is again the protocol that the callee will know about. So when the callee is executing the code for summing all these arguments up, it will know that it needs to load from each registers the values, 6 values, and add them to the result register. So it will move from, let's say, R9D, it will move to some stack position, a value, and then it will add that value, or so here it copies parameters and then it pushes them on the stack, and then from the stack it adds them, loads them into EAX register, and the result is stored in the EDX register, right? But again, it knows that the last parameter was stored on the stack, so it would get that from the stack and then add it to EAX register. And EAX register in this particular calling convention is the register that will have a result of that function, right? So again, a callee and the caller will have to know, so there is gonna be a binary protocol on how the parameters are being passed between each other. Yet another issue that comes with ABI is how you would present your fundamental types. So in C++, C++ doesn't tell you that the char is always 8 bits, but probably there is no currently widely used platform that it's not 8 bits. But still, the C++ is just telling you that the char is gonna be larger than 8 bits, or larger equal or 8 bits, and then any other type size will be larger than the char, right? So the same goes for short, and there are some mutations for integer, long, and long. And this is what ABI implements. So ABI implements these restrictions, and the compiler will say, okay, I assume that for me, char is 8 bits, right? I assume for me short is that and that. And the reason why C++ didn't give the hard rules on how to do it is that the compiler will choose whatever is the most performant for a given platform. Then another issue that comes again with ABI and fundamental type representation is that what is your integer? How is it stored in the binary representation? Is it to complement, or is it maybe stored as something else? Your floats, doubles, are they IEEE, IEEE 754 compatible? And then what is the endianness? That would probably come from your operating system, right? And all of that is handled by the compiler. So sorry, because I might be told off. No. All right. Yeah, so all of that is handled by the compiler and its specified ABI. Yet another problem with the ABI and fundamental type representation is that you would have the alignment limitations imposed on your types, and that means your primitive types, they wouldn't be stored anywhere in the memory. They would be put at the particular value of the memory where potentially access to that data is improved. Also, if you, for instance, have a structure and your data members of the structure, then all of those members wouldn't just stick to each other. They would be put in the memory of that structure, so that the performance of accessing those would be the best. And each of the types, they have something called the alignment. And the way how it works is, for instance, if you have a structure S with short, integer, long, and float just stacked next to each other, you would expect that to have a size of just summing the sizes of a particular type. However, it's not the case, because if each of those types, so short, B, integer, long, and float, they have different alignments, and you will have to take that into account, and also the account of the size of each integer. So if you have a look again on how this code is being translated by the compiler GCC x8664, is that it would show you that the first integer 1 stored into the short is going to be stored for, so it will, the short itself will take only 2 bytes, but then you wouldn't be storing an integer next to it, but it would pad to 2 bytes of zeros potentially, or whatever, an uninitialized memory, that structure, and only then it would put the integer. And the reason for that is that the alignment of integer is 4 bytes. So you would have to have 4 bytes preceding the structure beginning before the int starts, right? And then the long would be taking 3 bytes. You wouldn't have any alignment here because it already is on the align of 8 bytes, because we had two padding and 4 bytes, and then 4 bytes for a float, and then it would also pad it. And the reason for that following padding is that if you had those structures in the array, you would want to have consecutive structures as well padded. Then there is also, if we're talking about the compiler ABI and something platform specific, system specific, is that you have your object file format, which means you produce your library or you produce your executable, and it's not you somehow starting that executable or using that library. It's your operating system using that. So the operating system needs to know how to load it, how to start it, what are the entry points in it, and all of that would mean that your object, that your files will have to conform to object file format of your operating system. And common, just to let you know, that the common formats are ELF, P, that's Windows, that's Linux, Mac O is for Mac OS. I think they might be moving to ELF as well. Yeah, and so most of the time, most of the things I just mentioned, they are more or less C things specific, right? But there is much more things going on in the C++ world. And for instance, if you had a look at the name mangling, so the name mangling in C was pretty simple, right? But because C++ have overloads, it has classes and namespaces, the name mangling will have to include all of that information. Like in this example, you have a value function and then another function, and obviously the binary format needs to distinguish between those two. So we would have value void and value taking integer mangled in the name with some prefixes, right? And all of these manglings are compiler specific. Then if you had a namespace, that namespace would have to be taken into account also in the name mangling. If that was a member method of the object of the structure, then that would have to be taken into account as well. So C++ complicates that even more. Then comes also the inheritance. And you might have inheritance, so C++ allows for multiple inheritance, so you need to take into account the order of inheritance. Then you might have virtual methods. Usually the virtual methods are implemented as vtables, but then you have an option to store a pointer to a vtable at the beginning or at the end. So MSVC is, I think, adding that at the end. GCC and Clang are adding those at the beginning of your structures. Then you have exceptions and the way of handling those exceptions. Then you have also the runtime type introspection, and all of that is adding just to a bigger ABI of the C++. And yet another option is that C++ is using heavily templates and using its standard library, which is standard template library, and all of that code ends up also in your caller code when you compile, and that adds some problems to implement ABI and to keep ABI stable and simple. So is there any ABI standard? So no, we've already said that there is no C or C++ ABI standard. However, since most of the OSs are written in C, I know it's not the case anymore, but still the biggest OSs are written in C. They will have something like that operating system ABI standard, and that standard will be C compatible standard, right? And you can use that to get the interoperability of your program and the other programs. And obviously C++ has a subset of C++ is C, and it's natively supported. So C++ will be supporting those operating system ABIs. And usually any C compiler that C compiler, but we're talking about C here, right? Your compiler will try to conform to the given OS C ABI standard. So you should be pretty good about using the C part of all your libraries with your compiler. So there is no standard, but there is. That's usually the question that people are given on Stack Overflow and whenever you ask. And we also mentioned that, so previously that was the ABI of the compiler itself, right? But there is also that ABI of the library, which we said it's a combination of ABI of the compiler. And I didn't mention that before, but compiler, depending on the flags you pass in, it may change the ABI, and then it might produce code that is not compatible with the other code you've compiled using different flags, right? So you have to be careful about that. And that's what's scaring me the most, really, when I'm trying to use some other precompiled libraries. Yeah, so library API, ABI is compiler ABI with the library API. And the reason for that API is taken into account is that it leaks. And what it leaks the layout of the members, structures. It leaks information about the inheritance of types. It leaks information about what function it has, what templates. Some functions are also inline functions, so then they may end up in the code of the caller. So all of that is the ABI of the library. So if we want to make sure that we are compatible with the library ABI, we really need to make sure that the client and the library that the client is using, they agree on the ABI. And usually it's pretty easy when you compile everything from source and everything with the same compiler, and especially if you're statically linking everything. But it's not that easy if you're already using pre-built binaries, right? And some of the examples of that is, for instance, something probably you have encountered is that on MSVC, iterators are implemented differently. If you build your binary in debug, or you build your binary in release, and then if you're trying to use iterators produced from one type of the compilation with the other type of compilation, you would get into the problems. Thankfully, because that's a standard library, right? So thankfully the implementers will help you and they will indicate during the runtime that there is a problem of you using the different types of the iterators, right? And then you would basically have to make sure that all of the code is compiled with the same flags for debug and release. That's not only a problem on MSVC, right? So GCC standard library before C++ 11, when it was having a std string, it was using copy on write optimization. However, C++11 has forbidden that, and they moved to small buffer optimization. And it's working all fine, unless you are having a library that is using one and you as a client are using the other type. And then you would get the error if you're trying to link statically that library like that, or if you're trying to load dynamically, then you still would be given that error. Again, thankfully, implementers of the standard library, they're trying to overcome some of the limitations by naming those different, by having name mangling for those different strings different, and you're getting that error instead of just hitting the problem and getting some corruption of the memory. So these two were the real examples of the real breaking changes, you might say, of the ABI. But what else might be, in terms of library, what else might be breaking the ABI? And really is just adding, removing, changing order of any non-static members. And the reason for that is that they end up in the particular position of the structure from the structure root. And if the caller is trying to read something else that is trying to interpret as something else, then you're gonna get problems, right? Then also, if you're changing the class hierarchy, it will break your ABI, because those class hierarchies, they're basically flattened out. If you unexport some symbols, then the caller will basically not be able, if they're using those symbols, they will not be able to find those symbols, and probably you will get the linker errors. If you remove finality, if you change some function signatures, parameters, return types, they all contribute to the name mangling, so you would end up with different symbols. Yeah, and if you change any virtual functions, that's a tricky one, because then you would be basically calling the code that you're thinking you're calling, and you would be redirected to some other call that was at the particular position of the vtable at the point when you compile your client, and this is very problematic one. There are many more of those things that can break ABI, and I put a link here that has a lot of those listed. I think that these are the most probable changes that probably you as a library implementer would do, but there are many more that you shouldn't be doing. So lots of the, it's easy to break the compatibility, right? But lots of the libraries, especially the C++ standard libraries, they treat ABI breaking changes seriously. And GCC and Clang, they try to be backward compatible as far as they can, right? So usually you should be able to use like the old version. So it's backward compatible. So if you compile your code and you're using the library that is using some other GCC or Clang standard library from the past, you should be still good to go. MSVC didn't keep that backward compatibility, and that was their choice, explicit choice. But since MSVC 2015, it seems that they are keeping the backward compatibility as well. And obviously, there are ways to prevent breaking the compatibility, like Pimple idiom. There are ways of checking your compatibility with the newer versions of the libraries. Like you can use the ABI compatibility checker. They are not giving you 100% of certainty that they will work or not, but it's still something potentially useful that you should be doing. Yeah, and so that would be the ABI of the compiler, ABI of the library. But I said also that the OS is having its own ABI, and usually that ABI is C. So I'm running the Linux and operating system, and that has the C OS ABI. And we can use that ABI for our own good, right? For instance, we are able to call C++ from Rust, and C++ from Rust, provided that we are all using the common language, common protocol of the C library, of the C ABI, right? And the way how we would be going about that is we create the library with C interface in C++. So having a CMake list, very simple, just adding one CPP file and saying that we are producing a shared library, then that step is not really necessary. It would be necessary if some other C, C++ libraries were using it. But it's just basically saying, I'm exporting a function which is grid from CPP, but don't mangle any name by using extern C. And then we are having a CPP file with the implementation of that function using the CPP idioms and CPP STL IOStream, for instance, right? So this is to show that we are really using C++, even though we're going through the C interface. So that is a simple implementation of that C++ library with the C interface. The way how we would build it is just saying CMake configure, CMake build. I have GCC as a standard compiler, so it would pick it up. And that produces libcpp libso shared library. If I try to read some name symbols from that shared object, you would be able to see that on line 18, there is a symbol for my grids from CPP. It's not mangled, which means it's really taking into account that information as an extern C, right? So how are we able to call that function from Rust? We will have to create a TOML, which is using libc dependencies. There are many ways of doing it. This one is just like the bare bones of doing it, right? In the Rust file, we would basically say that there is an external information there is an external symbol defined in the CPP lib that will have a function name grid from CPP. And we would need to manually basically say that it is having libc char pointer or constant char pointer to that depicts the name, right? And then we can easily use that function saying we create a C string in Rust and we assign it to the variable, right? And that has to be a C string. And we would be passing this as pointer to the function grid from CPP that would basically be calling the function in the CPP code. And it will work here because we know that Rust is doing UTF-8, but since we're using simple ASCII characters, then UTF-8 for those is the same as ASCII for C++, and C++ is basically ASCII, right? This is the way to compile it. And then the way how you would run it is you would specify on Linux where the library is being stored, the path to the library where the library is stored. So this is a C++ library, cpplib, which would be named libcpp libso, and then we would be running hello world, and that would be calling hello world from C++ using the Rust C string defined in Rust. There is also the other way we can do. We can call Rust code from C++ using the same C interface. And the way how we would do it, again, is we would say that we are creating a dlib. So I'm always creating shared objects here. We could be doing as well static libraries, right? Again, we're using libc to define the C types. And we export the function without mangling grid from Rust that is taking in a constant pointer to C char. Then unsafely we would demangle it to C string, and then we would just say print ln hello from Rust for whatever we have passed from C++. Easily building it. The artifact that is given to us is librust libso, and then if I check names from that libso, I can see that there is a name in the text section, grid from Rust, not mangled. So that asserts me that something is going okay. And the way how you would use it from the C++ side, the CMake project would be basically saying we're having a CPP caller using main CPP, but we're also trying to find Rust library. So that's the one that we just produced. And we're linking that Rust library to the CPP caller executable. Then we would have to say again, so this is we would have to declare that there is somewhere that function that is called greet from Rust, and takes a pointer to const char, and we would just basically call it like this with pointer to const char, right? Compile it and call it, and we would have the Rust code presenting the C++ from C++ string from C++. Yeah, and that would be all. Hopefully I didn't lose anyone there. So there are some references, right? I was saying that Titus Winters, he's from Google. He's maintaining Google library AppSale, and he's proposing to break ABI now, not or never. So C++ is not really saying, oh, we're not breaking ABI, but C++ committee is really considerate when there is a new feature and it would break ABI. So basically we are ABI stable, but we're not saying that to anyone. And there are some really nice talks from CPP now in 2019, the ABI challenge from Arvid Norberg. If you listen to that talk, then you're basically scared of using any other precompiled objects, libraries. Also, the Louis Dion, I think he's from Apple. He's giving his talk about ABI. And there is also a nice read, or I had it in form of slides, but apparently there's somewhere a talk also about the ABI. Yeah, and I think that would be all. If you have any questions, I will hopefully be able to answer them. So this is mangled, CPP mangled, GCC XA6486 mangled for that function.
That was great. Thanks, Krzysztof. I'm sure people probably have questions. I think Richard had to shoot on, but what you were saying about keeping release and debug, that they're usually not compatible. So that's something that we've hit in our company. So the part of code that Richard works on is called Maplex, and it does quite a lot of work. So in debug, it's horrifically slow. So they've been quite careful to make sure that the interface between Maplex and the rest of the code base will be compatible, even if Maplex is in release and everything else is in debug. So that they don't need to have Maplex in debug in order to do when they do a full debug build.
Do you know what kind of interface is that? Is it C++?
It's a lot of pointers.
Oh yeah.
Because
so usually how you go about it, right, is you have a C library, but you are producing a C++ wrapper around it. So C++ wrapper is the one that is compiled into your code, but it's managing that C code that is already held in the library as well, right? So you might be using C++, and it just hides all the nitty-gritties and all the problems of C code of the other library.
Yeah, I'll have to get them to explain exactly how they've done it, because we also had some issues with some of the draw code, again, because it's highly optimized code. So when you have it in debug, it's very, very slow. So they were looking at, I think they decided, and they explored different options of whether or not to have debug, but with a release build, but with optimizations off to mean that you kind of have a halfway house. And in the end, they went down a route of I think they ripped out a lot of the standard library containers and used their own implementation that doesn't do all the checking, so that they could still have a lot of the benefits of those containers, but not have terrible debug performance. But they only done that recently. I don't know the full details, but I think Richard was on the code review, but he's had to go. So definitely, I'll have to ask him about it next time we do a meetup.
All right.
Did anyone have any questions?
Hello, I have a question.
All right.
How do you go about inspecting the code after it's been compiled?
So there is that tool, ABI checker, And in fact, they are having, obviously I don't know how to use it now. So yeah, there is that tool ABI checker, and it is being run currently for some Linux distributions, if I remember well, right? Automatically for different libraries, and you can see how the libraries are ABI compatible with the previous versions of those libraries. Obviously, it's not gonna catch everything, right? But it's gonna catch, for instance, the different name mangling. So it produces names, symbols for each versions of the libraries, and then it finds out if something has been removed that was publicly available. And if it's the case, then it would tell you that your ABI is not compatible with the previous version, for instance. Obviously, you still would be able potentially to use it if no one has been using that particular symbol. I think the GCC is by default exposing all the symbols that you have in your CPP or in all your projects, right? Unless they're having explicit internal linkage. MSVC is doing that the other way around, so they don't expose anything unless you explicitly say it should be exposed, for instance, for a shell library. So that ABI checker, I think it can also, so you would have to have symbols. I didn't say that, right? So you would have to have debug symbols to get some more verification of your code. And if you have those, it would be able also to tell you that your structures that you're returning, you're consuming inside your API of the precompiled library hasn't changed so that they can break something. So this tool would give you some certainty of not breaking ABI, but I don't think there is a way of saying like, oh, I'm 100% compatible. And that's the scariest thing about it. So there is lots of people basically assuming, oh, ABI is the same, right? And I'm just gonna be using that shared object, but really it's not necessarily. And it's like driving on the motorway and or not motorway, on a normal road and trusting the other users that cross that you go against, that they're not just driving into you, not hitting into you, right? A little bit like that. Does that answer your question?
Yeah, thank you. And great talk, by the way.
Thank you. Oh, and I finished it. Wow.
No fires at home now?
Sorry?
Nothing's on fire now at home.
No, no, no.
Even if it was, you couldn't leave.
Yeah. Oh, in fact, I'm on quarantine, right? So yeah, I still have like 11 days to go.
Well, while you were giving the talk, we all came under quarantine. We're not allowed out now.
Oh, right.
Yeah.
Oh,
It's all right. I'm halfway through.
Yeah, my phone was buzzing all the way through your talk, Krzysztof.
oh, I missed that. Oh, we're properly
Oh,
locked.
it's worse now. The police have got power now as well to arrest
Mm.
and to fine.
Well, it's a good thing that we've nailed down how to do a virtual meetup. So
That implies this has gone well.
Yeah.
So
Should be good.
no drama. We're going to have so much time now to work on any future talks.
Unless you have babies.
Unless you have children, yeah. Because I feel like I got less time than we've ever.
Yes, especially if he's not going to nursery. Or...
I've obviously been isolated for longer, and it's not good.
I
can feel your pain.
I saw a great post about how to do a pub crawl from home. So I live in Canton, and so it kind of listed the different things, and it was like, okay, sit outside your porch until your hands get really cold, and that's to pretend that you're at Pipes Brewery, which is outside, and like you go to the next pub where you have to dress up or something, and then It was great. So there are things you can do at home. People have invented great ideas to do things like pub crawls.
Can you share that in
I've
the
done a
chat?
couple of Zoom
Oh,
drinking
sure.
things.
Thank you.
Yeah, definitely.
Okay, I'm going to get it from my phone somehow on the. How is everyone coping?
It's
So
not been
How
too
many more
bad.
days?
yeah, we are pretty lucky, right, that we can work from home. Like
Yeah.
most of the time,
Yeah.
it doesn't really affect us. You can do your stand-ups, you can do whatever meetings you have online, and then you just smash your keyboard. Yeah, other people are less lucky than us. But I think you, Ciara, mentioned that already on Twitter, right?
Yeah, I was definitely feeling very fortunate to not have to fear for my job while things are going a bit up in the air.
I've recently
Yeah.
moved and my fish is still in my apartment. I can't go feed them.
And you've gone quite quiet, would you say?
Oh, sorry. Let me just turn the volume up. Yeah, is it to sound better now?
Yes.
Much better.
Okay, cool. Yeah, I just turned the volume up. Yeah, I mean, I've just moved it, and my fish is still in my apartment, and I can't go feed them. So yeah,
Oh, no.
I get it. I know.
Is there anyone there who can feed upon your behalf?
No.
Oh no.
Yeah. So, have to sneak outside.
You have to put out an appeal like, can someone feed my fish?
But yeah, you also would have to allow smashing your doors for anyone random to feed your fish.
Yeah.
I think it went pretty well, right? Without any technical hiccups. Yeah, Ewan, he disconnected for a while, but it was good, I think. We can do it more often.
I think it worked quite well overall.
Yeah, I thought it was good.
We could keep that every second month, or up to
Well, for
every
now,
month.
it's going to have to be every month because we can't really run a workshop remotely. It's going to be pretty tricky to do that, isn't it? Because people need a support. So maybe just the same thing next month, maybe?
We can try.
Yeah,
I
I don't want to give. I assumed in a presentation of software has been written in Rust.
No, I don't think they have actually. We've kind of half mentioned the odd bit, but nothing in depth.
Okay, yeah, cool. I'd like to maybe do a presentation on that.
Yeah, that'd be great.
That's okay. Yeah, cool.
Awesome.
That'd be awesome. Yeah.
Do you want to give us your details and we can get in contact in a more official manner?
Yeah, that sounds good.
Do you want to?
Always somebody thinking about the actual particulars.
Do you want to drop your contact details in the channel, and then we can introduce you to a WhatsApp group, and we can talk further? Is that a good idea?
Yeah, that's cool. Yeah.
So who's going to edit the video?
Oh, the video is going to be perfect right out of the box. It's not going to need it. I can tell.
I don't know. You got to take all my mumbles and my ums and my ahs, and when I messed up a bit, I would like cut out. And can you do my hair a bit pinker? I'm just trolling.
Okay, I don't seem to be able to send pictures in the chat, but I'll share the pub crawl. If I quickly share my screen now, you can see it. So, there you go. Someone made a little pub crawl to do in Canton, but from the comfort of your own home.
Oh, let me print screen it.
Of course, it relies on having beer in your house, which we're locked down. you know, I didn't think. All I've got is gin. Like, this is not going to do. Shop.
It was my
Like if-
birthday
when you
yesterday,
go
so I got a
to-
well-stocked cupboard.
Nice.
I have 6 bottles of lager.
Is that going to last the 3 months you're trapped indoors?
With the recent rate, it's more than 3 weeks to last for.
You're allowed to go to the shopping, but as little as possible is the rules.
And probably as a single
Right.
person, like in Italy.
That's not been specified yet, but if there's collections of people, they got rights to disperse.
Yeah.
So let's conform to the rules and let's fight that shit quick, right?
Yeah. Hopefully, if we all stay indoors just completely for the next 2 weeks, in theory, everyone will have fought it and then we'll be fine. But in reality,
I
Exactly.
think that's what
do that.
Boris said. 3 weeks. 3 weeks of this, and if people follow it, then it should break the back of it, and we'll see where we are.
Unless there is that one person carrier and that happens again, right?
So people
Oh, there's going to be
listening.
them.
So people listening, the evening, the meetup has finished. So we have moved on to other topics. So you are free to leave before this devolves into more off-topic
I mean,
conversation.
they were free to leave at any time, right?
No.
Now they were locked down into this meetup.
Oh, we lost you there, Dan. Couldn't hear you.
No, I was telling Google to change the lights,
Ah.
so I wanted to make myself.
Okay, so we just need to plan our next one next month, maybe.
Yeah,
So-
anyone who wanted to, if anyone wants the email and doesn't have it, just message one of us on meetup.com. You should be able to see us as one of the organisers, and then we can send it to you, or you can tweet us, and we can move communications to whatever channel you find easiest. So there's Slack, but there's also WhatsApp if you prefer, or just meetup.com. Yeah, I think Kit, if you're still there, I think you promised to talk at some point early this year. No excuse now.
None at all.
I don't know if you can hear us. It was like a sound.
He said he can. He could.
Okay.
But he wrote that to me, right?
Okay, I've got to shoot on now, so I will probably. I think I need to end the meeting because I'm the one who organised it. Happy if I
Thanks, Ciara.
Safe
Thank you,
coding,
everyone.
guys. Thank you.
Have a nice
Safe
Christmas.
coding.
Bye.
Thank you, everyone.
Bye-bye.
Bye.
Bye.
Bye.